So, last problem of homework, example problem of homework 31. Going to do example problem number 4. So we have 3 premises and a conclusion. Premise 1, premise 2, simple proposition A is premise 3, and then simple proposition B is the conclusion. So let's go ahead and highlight the main operators. So A, if and only if. B, the main operator is going to be the biconditional. Not B, not A are each their own entities. So the main operator is going to be the conditional. And then, of course, simple proposition A, simple proposition B is what we're going to be looking for though. So we're going to have to fill out, in order to find a row that invalidates the argument as a whole, we're going to have true, 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 false. So let's go ahead and fill that out. True, 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 false. All right. So, as you can notice right away, we already have truth values for both A and B, which are the only 2 variables that we have. And again, the truth values of any proposition is going to be consistent throughout the argument. So, fill out true for A and false for B. And already we have a contradiction. If and only if the biconditional is only true if the truth values match. So, in other words, for this to be true, both A and B would have to be true, or both A and B would have to be false. But since they're different, this should actually be false. So already we have a contradiction with these. So that means that we can't find a row that invalidates the argument. And if we can't find a row that invalidates the argument, this is going to be valid. I believe on this one, even if we had carried it through, let's go ahead and, just for extra practice, go ahead and carry through for the second premise. So B is false, which means that the negation is true. A is true, which means that the negation is false. So we're looking at this true, this false, and as you remember, the only time that a conditional is false is when you have a true antecedent, false consequent, which we do. So that means that this should actually be false, and we have already filled it in as true. So we actually have 2 contradictions if you keep going through it. But we don't need it. Either one of these would prove that you can't make a line that invalidates the argument. Otherwise, it's valid.